Assalamualaikum warahmatullahi wabarakatuh. So this video is about industrial electronic lab for electro-pneumatic and electro-hydraulic system, and we are from section 4, and my name is Ahmad Usamah bin Nazar, and my metric number AA32003.
My name is Azim. My metric number is AA191548. Now we would like to talk about the lab activity 1. We have two circuits which are electro-pneumatic and hydraulic and electro-hydraulic circuit. For the both of the circuit, we have to set the cylinder stroke to 200 mm and print screen the completed diagram. So this is the circuit that I built in FluidSim. This one is the first circuit, which is electro-pneumatic circuit. Let's take a look for this circuit. The parameter, set the stroke to 200. Let's run the circuit. At rest, the air is flowing from air supply through this valve and cut off here, which the air does not flow up to the cylinder. But when I press the valve, the air will flow through this valve and fill up the front part of the cylinder. So when the head of the piston hit the 1B1, this switch, which was normally closed, will become open. When I left the valve, the switch will become closed as soon as the head of the piston left 1B1 label part. So that is if I mechanically push the valve. The other way to make the cylinder move is by push the S1 switch. When I push the S1 switch, the current will flow through here, and this K1 switch will become closed, and the 1-1 solenoid valve will get energized and make this valve to move to the right, as we can see here. So when the piston, as I mentioned before, when the head of the piston hit the 1B1 area, this 1B1 switch, which is normally closed, become open and make the K1 relay de-energized, making the switch to become open. This action will stop the current flowing to the solenoid valve, and the valve here will back to the original position where it does not allow the air pass through it and go to the cylinder. Let's watch it. So this is how the system works. The next circuit is electro-hydraulic circuit. So this is the circuit. Firstly, check the parameter. It is set to 200 mm stroke. Let's run the circuit. At rest, the water is flowing from the supply to the back part of the valve, and it's not going to the cylinder. So when I mechanically press the valve, the water will fill up the upper part of the cylinder, the piston at 1B1 position. This 1B1 switch, which was normally closed, will become open. So when I release the valve, the fluid from the cylinder will flow through this path and fill up the tank here. Let's watch again. This is how the tank will fill up when I press the valve mechanically. Another way is by electrical move, which I press the S1 switch here. When I push the S1 switch, the current will flow through this path and will pass by the 1B1, which is already closed, and make the K1 relay coil to get energized, and both of the K1 relay contacts will become closed. The 1Y solenoid valve will get energized and make the valve move to the right. But the system works only until the piston reach the 1B1 position here. After the piston reach the 1B1 posted here, this normally closed switch will become open and making the relay coil K1 de-energized, and both of the K1 switch will become open. The solenoid valve 1Y here will also de-energized, and valve will go back to the original position, and making the fluid from the cylinder will fill up the tank. Let's see the simulation. As we can see, once I press the S1 switch, the piston will contract and extract in one action. We don't have to push it again to make the piston come back to its original position. Let's watch again. This is how the electro-hydraulic system works, and this is how the fluid is filling up the tank here.
This is actually the tank. In hydraulic, tank is a container for holding the fluid required to supply the system, including a reserve to cover any losses from minor leakage and evaporation. So this tank is actually can be designed to provide space for fluid expansion, permit air entering in the fluid to escape, and to help cool fluid. So the second one is a air compressor. Air compressor is a pneumatic device that converts power into potential energy stored in pressurized air. As example, a compressed air by one of several methods. An air compressor forces more and more air into a storage tank, and increasing the pressure. When the tank's pressure reaches its limit, the air compressor shuts off, and the compressed air then is held in the tank until called into use. Question 1. Describe the difference between electro-pneumatic and electro-hydraulic system. Basically, these two operations is the same. So what makes it different is actually in electro-pneumatic circuit, the supply is air compressed, but then in electro-hydraulic circuit, the supply is a tank, which is in electro-hydraulic is using fluid as the supply, and in electro-pneumatic circuit it is using air supply. So that's the difference. Question number 2. Describe an industrial application for electro-pneumatic and electro-hydraulic system shown in figure 1. In electro-pneumatic system, it uses electrical technologies to control the compressed air used as working medium. So, electrical devices such as solenoid, limit switch, valves, and relays are some of the mechanisms used in typical electro-pneumatic setup. Electrical power is applied to a directional control valve. In industry, automation technology (ATI) has introduced an electro-hydraulic control system, adding to its range of valve actuators and controls. So the product can be directly mounted to a linear or quarter-turn spring return or double-acting actuator to perform critical shutdowns even when a power source is unavailable. The electro-hydraulic system can be provided for either non-hazardous area or hazardous area rate service. So the electro-hydraulic circuit consists of a power module and a control module. So the power module includes an electrical motor, a single direction hydraulic pump with reservoir, a valve manifold, and a power supply for control components.
Okay, so for lab activity 2. Number 1. Develop the electro-pneumatic diagram figure 2 in fluid sim software. Hint: 1v1 is a normally open switch. Number 2, screenshot the completed diagram. And the last one is record a simple video to explain the operation of the circuit. So let's move to the circuit. As you can see, on the left side is the pneumatic diagram, and on the right side is the electrical diagram. To run the simulation, you must click button play right here. Before I press the push button over here, let me explain the electrical diagram of this pneumatic circuit. Basically, as we know, 1v1 and 1v2 is normally open. Limit switch. Whenever it reaches the limit, the circuit will become open circuit. When I push the push button here, S1, the current will flow through it and it's going to energize the relay coil over here at K1. So when K1 is fully energized, the switch over here will be triggered and become in a close contact. As we can see here, here is the limit switch. Whenever the limit switch operates, it's going to energize relay coil over K2. Here got switch. When K2 is fully energized, the switch over K2 here will become closed. When K1 and K2 in closed circuit, one M1 will be triggered and it is going to move the actuator over here. Same goes to this 1B2. Whenever it reaches the limit, it is in an open circuit. And this one also operates the same way. So whenever 1B2 is in a closed circuit, the K3 relay will be energized and the K3 switch will become in a closed circuit and it's going to trigger one M2 and this going to operate repeatedly. Finally, let's try the simulation. When I push the push button, the operation will stop and the cylinder will become in the original position.
Observation 1. State the name of component 1B1 and 1B2. As we can see in electrical diagram, 1B1 and 1B2 are limit switches where 1B1 is normally open limit switch while 1B2 is normally closed limit switch. Observation number 2. Briefly discuss the function of 1B1 and 1B2 in the circuit diagram. 1B1 and 1B2 switches are limit switch. The function of the limit switch is to control the machinery as a part of the control system. Here, the 1B1 and 1B2 are to control the electric current flowing through them when the switch S1 is pressed. So both 1B1 and 1B2 will let the current flow when the amount of current flowing through is in between the range of the current that the circuit or the system can handle. But when the current is exceeding the limit switch 1B1 and 1B2 will prevent the current from overflowing, and that is the function of 1B1 and 1B2. Number 3. During simulation, a symbol with an arrow always appears next to the component in electrical diagram. Describe what do you understand when you see the symbol. From the simulation, I understand that the symbol arrow pointing upwards will appear at the component that are in work. When the current is flowing through the component, the arrow will appear beside the components. When the current is not flowing through the component, which is, for example, when the switch at the component is open, so that components in line with the open switch, the arrow will never appear. So what I conclude from the observation is this arrow will only appear beside the components that the current is flowing through. Questions number 1. Discuss the importance of component A in actual industry application. A is actually an air service unit. This represents after a compressor in a pneumatic circuit. The function of this component is to remove dust particles, humidity, moisture, and ice from the compressed air, and there are several parts in the air service unit, which is also called as air preparation system. The first one is a filter, which is it removes the impurities present in the compressed air supply before it is delivered to pneumatic components. Then the second one is pressure regulator, which is it allows us to regulate pressure manually, and the last one is lubricator, which is it provides lubrication for pneumatic components.
Okay, let's move to lab activity 3. Develop the electro-pneumatic diagram figure 3 in Fluid Sim software. Screenshot the completed diagram and record a simple video to explain the operation of the circuit. This is a pneumatic diagram and this is an electrical diagram. These two diagrams are connected to each other. Firstly, we run. We can see that the connection for the pneumatic has been done and also the connection for the electrical diagram. Now to understand better, from here, the valve is already in the left position. So in order for it to shift, we will manually push so the valve to slide to the right. And then we can already see that the compressed air has already been passed into the space. That is why the piston is not extended. We are moving to the electrical diagram. From here, the connection has already been done and this is a switch. So push the detent switch, it made a connection here. The circuit is completed. So we can also see that there is a counter here. Counter has been set to 5. Now let's move to pneumatic diagram and see the changes we made after the valve slide to the right. Now, the compressed air has already been passed into the space here. The piston will be extended and the remaining air behind the piston will be passed to the exhaust. Now for the electrical diagram, we can already see that the counter has been count down. It has reduced to 4. Repeat the same action. Now, the counter has been set to 3. Okay, now the counter has already become a 0. In order for the counter to become 5 again, we press the S2 here. Then the counter will be set to 5. That is how the circuit diagram for pneumatic diagram and electrical diagram works.
Observation number 1 for lab activity 3. Tabulate the list of components used in figure 3. For the circuit 1, component number 1 compressed air supply, and component number 2 air service units, component number 3 5 and way valve, and component number 4 double-acting cylinder. For the circuit number 2, first component is electrical connection 24 volt. Second component relay and relay counter, valve solenoid, mag switch, brake switch, push button, detent switch, and last component magnetic proximity switch.
Okay, so observation number 2. Explain the function of S2. S2 here will act as a reset button for the counter to set back from 0 to 5. So let's say counter is 0, so we reset the counter.
Question number 1. The position of 1B1 and 1B2 in figure 3 is different from figure 2 by referring to components A and B below. Are both types practical for 1B1 and 1B2 in figure 3? Explain your answer. The components A and component B, they are actually at the same position. So what we can conclude between these two lab activities, both of them actually serve the same purpose. However, the limit switch and the magnetic proximity switch can be slightly different due to how it works. So component A, this is a limit switch. It may be mechanically operated by the motion of the operating lever. However, for the magnetic proximity switch, it has a red switch which indicate the proximity of the magnet, and the proximity switch is mostly used and also conduct because of the disturbance of an electromagnetic field caused by the capacitance or also by sensing magnetic field. So from what we can figure out, both types are practical for 1B1 and 1B2 can actually serve the same purpose. They actually serve the same purpose, and the electrical diagram are also connected to the pneumatic diagram.